Hi, I'm Sanket and this is my friend Ria.
Hi.
Over the last 4 episodes, we dived deeper into the data science terminology and learned about data collection, data handling, inferring from the data, supervised learning, and self organization of data. This now brings us to the next most important segment in data science big data, which we are going to cover in this episode.
Remember how your personal computer, with its modestly sized memory, allows for adequate storage of your movie collection, documents, personal photographs, spreadsheets, and many other things? You could even set up a fully functioning professional level database on your personal computer. Of course, limited to the size of a few gigabytes. Now, do you remember the concept of training data from the episode of supervised learning? How will you train your model when the size of the training data becomes too big to fit on the hard drive of your personal computer? Or what if training the model starts to take hours?
I can think of one possible solution, which is to shift your data analysis or machine learning to a larger computer that has access to more storage and control it from your smaller computer.
Correct. This is the idea behind big data and cloud. While the training happens in the background on a different computer, you can grab a coffee, check your emails, and read the news. But how does this other larger computer work? How does it handle large data sets?
Well, rather than storing a dataset in one single piece, you can break it down into multiple pieces and store it in multiple hard drives. This is the idea behind distributed storage. With big data technology, you can also read and process different pieces of the file in parallel. This is called distributed processing.
Let us explain this to you with the help of an example. You want to read a dataset that is 100 terabyte in size. Let's say your hard drive, where this data is located, has a reading speed of 100 Mbps. How long do you think it will take to read the data? In the most ideal scenario, it will take at least 12 days to read this data.
Now let's say you store this data on 1000 hard drives and use distributed processing to carry out distributed data reads. You will be able to read this data in a short 17 minutes. Yes, do you see the difference? This is the importance of distributed storage and distributed processing.
Big data technology that employs these concepts of distributed storage and distributed processing is typically divided into two major kinds. There is the operational big data technology, and then there is the analytical big data technology. Analytical big data technology harnesses the raw data stored and processed by operational big data technology. Let us walk you through some of the most important big data tools that are used in organizations today for operational and analytical purposes. The best thing is that you will get to experience using all of these tools hands-on in the upGrad Data Science course.
Hadoop is a distributed storage and distributed processing system for big data which is based on the MapReduce framework. Such systems have the advantage of being easily scalable, being fault tolerant, they are inexpensive to implement and flexible for working with any kinds of data.
The next such important big data tool is Scoop. It helps you load large volumes of data from multiple sources such as other Hadoop clusters and relational databases.
Let's move on to the next important big data tool, Hive, which is commonly used by data scientists to query data sitting in Hadoop. Here is Mr. Joydeep Sen Sharma, one of the creators of Hive, speaking about the history of this technology.
One of the things we realized was that in order to have a successful Hadoop deployment, ideally we would like to open up the power of Hadoop to as many users as possible. And when we looked at the kind of programmatic interfaces that most people knew, we quickly realized that SQL was the single most dominant analytics programming language that almost everybody who was technically sort of inclined in the company knew. At the same time, we also saw that engineers used to love programming in Python. That was sort of a favorite sort of analytics language inside Facebook. And we decided that, let us try to create a environment where people can write analytics sort of jobs and queries using a mix of SQL and first-class programming languages like Python.
Now let's move on to the next important big data tool, Apache Spark. It is used to perform exploratory data analysis, or EDA, on big data sets to develop machine learning algorithms and to perform near real-time analyses. In the upGrad Data Science course's case study section, you would be performing an EDA on a dataset with more than 4 crore rows using this big data technology called Apache Spark.
This dataset is about New York City's parking tickets. NYC, as you must be aware, is a thriving metro, and one of the biggest challenges the public there faces is parking, given the huge number of cars and the cramped geography. Parking tickets are very common in NYC, and a dataset collected by the NYC Police Department on parking tickets is publicly available on a platform called Kaggle.
The skills of performing an EDA using Apache Spark can be extended to any other dataset and business situation. Hence, this case study will be helpful to you in the future as you go forward into building your data science career.
In the upGrad Data Science course, you will not only be learning the tools Apache Spark and Hive, but also the other important big data tools like Scoop and Hadoop to equip you well with all the skill sets. Shoot up your learning graph and join upGrad, your lifelong learning partner, to enroll for the data science course right now.